Hello! In the previous video we saw how to solve an ODE using the Euler method. In this video we're going to use the Heun's method. So let's assume this first order ODE with the initial value of y0 is 1 and a step of 0.2. So our first point is 0 and then we take a step of 0.1, bring us our next point. Exactly as we did with Euler, we'll come at 0, plot the initial value condition, in this case x0, y is 1, and we are going to ask the ODE to tell us the slope at this point. And that's why we've written the ODE in this form. dy dt is the slope, okay, and that's the slope at point 0. And on this slope, we'll extrapolate and find the Euler approximation at 0.2. In Heun's method, we'll call this the predictor. So, at the predictor, we'll ask the ODE again for the slope. So we have dy dt at t is 0.2, and the slope will be this blue line. The next step is to bring the slope at our initial value, and now instead of extrapolating on the first red slope, we'll find the average, let's say in green, and extrapolate to our next step and find this point that we will call corrector. Okay, let's try to put some numbers into this. So we start with t, 0, 0.2, 0.4, and so on. Okay. And then we have our y predictor. Usually we mark it with a star. And our y corrector. So for the initial value, we know the y corrector is the initial value, 1. Now, finding the next predictor, it's pretty much like the Euler method. We come at this point, take the slope, and come on the next step. So this will be the previous point, which is 1, plus the slope at the previous point. So in this case, it's minus y, so minus 1 plus t, t0 plus 1, okay, multiplied by the step. So this is equal to 1. Now, to find the corrector, we need, as we did with Euler method, the previous, okay, plus the average of the slopes in the previous point and the predictor, the next point, multiplied by the step. So this will give us the corrector. So let's put some numbers here. So 1 plus the step is 0.2 divided by 2 because we want the average slope, and then we add the slope at the previous point, so 0 and 1 inputted in this OD will give us the slope at the previous point, so minus 1 plus 0 plus 1, the slope at 0, and the slope at 0.1 will be minus y predictor now, so that's 1, plus t is 0.2, plus 1. And that equals to 1.8. So to calculate the next step, from 0.2 to 0.4, we're going to use the same procedure. We'll come at the corrector, find the slope of the ODE at the corrector of 0.2. Okay, this will give us, let's say, this slope. Okay, that's the predictor point here. At the predictor, we're going to ask again the function, the ODE function for the slope. Let's say this is the slope at 0.4. We'll bring it at the corrector, find the average slope, and from the average slope, find the new corrector over here. So let's calculate this. So at 0.4, the predictor is going to be the previous point, so 1.8, plus the slope at 0.2, so this red line, which we find by substituting in the ODE the y and t, so the y previous corrector and the previous t, so that will be minus 1.8 plus 0.2 plus 1 times the step 0.2, that equals 1.68. So to find the corrector now, as we did in the previous step, we need to take this point here, so 1.8 plus the step over 2. We said the over 2 implies the average of the two slopes, and the two slopes are at the previous point here, so that's going to be y 1.8 and t 0.2 placed into this equation, so minus 1.8 plus 0.2 plus 1, and the slope on the new predictor over here is going to be minus y. Okay, so y now is 1.68 minus 1.68 plus t is 0.4 plus 1, and that equals 1.78. So in the same way, we can continue moving down the t axis and solve this ODE